In this question, we have an electric circuit that contains the data as given in the figure, and we need to find the readings of ammeter and voltmeter. Now, if you have more than one battery connected in the circuit, that means you have to apply Kirchhoff rules. And before we apply Kirchhoff rule, let us look at whether we can make this circuit a bit simpler. So let us first label the circuit component. I will call this as R1, R2, R3, and R4. Now, before we apply Kirchhoff rule, let us see if we can simplify the circuit. Resistor R2 and R3 are connected in parallel to each other without anything in between them. So I can combine them together and write their equivalent resistance as R23, which will be 1 over R2 plus 1 over R3 raised to negative 1. That gives you 1 over 6 plus 1 over 3 raised to negative 1. And their combined resistance becomes 2 ohm. After we combine them, we can reconstruct the circuit. The new circuit becomes something like this. This is R1. This is the combined resistor R23, and this is R4. Now let's label the circuit. I will call this point as A, B, C, D, E, and F. After we label them, we will show the direction of current. So I'm going to show a current coming out of the 8-volt battery. Let me call this current I1. Then another current coming out of the 7-volt battery. We will call this I2. Current I1 as it passes through the circuit. Part of it going through resistor R23. We will call this current I3. The other part flowing through the next branch, which is already current I2. Now you can determine the direction of current however you want. And if your chosen direction is not same as the actual current, the answer you get will be negative. So I usually take the currents coming out from the positive terminal of the battery. Then at a specific junction, you can divide them. When you're dividing them, make sure you choose the same current if they belong to the same part of the circuit and don't label them as a new current. Now we choose the direction of traversing. We have two loops over here and the direction of traversing must be the same through both. So we will go around the loop in counterclockwise sense. Once you choose the direction of traversing, please do not change this later in the problem. Both of them must be in the same direction. Then next we apply Kirchhoff junction rule at junction F. So we write at F. From Kirchhoff junction rule, we know that sum of all current which are entering the junction must be equal to sum of current which are leaving the junction. So at F, the current entering the junction is I1. So we write I1 to be equal to I2 and I3 are leaving the junction. So we write this to be equal to I2 plus I3. Bring them all to one side. We get I1 minus I2 minus I3 to be equal to 0. We will call this as equation 1. Then we apply Kirchhoff loop rule to loop A, F, C, B and back to A. When you go from A to F and from F to C, you're going in the same direction as the current. And if you go in the same direction as current, potential drop across the resistor must be negative. Potential drop across a resistor is given as the product of current through the resistor into its resistance. So we write potential drop across R23 as R23, which is 2 times I3. Again, when we go from C to B, we are going in the same direction as current I1. So potential drop across R1 we will write as minus 5 times I1. When going from B to A, we enter negative terminal of the battery. So we take this potential difference to be positive. That is equal to 0. Now let's move 8 to the other side and rearrange this. I get negative 5 I1 minus 2 I3 equals minus 8. Remove the minus sign, you get 5 I1 plus 2 I3 equals 8. We call this as equation 2. Then we apply the same rule to loop F, E, D, C, F. Going from F to E and from E to D, we are going in the same direction as current I2. So potential drop across R4 will be negative 9 times I2. Then from D to C, we are entering negative terminal of the battery, so potential drop will be positive. Going from C to F, we are going in direction opposite to current I3, so again potential drop will be positive. So we write this as positive 2 times I3, and this is equal to 0. Now move 7 to the other side, you get negative 9 I2 plus 2 times I3 equals negative 7. We will call this as equation 3. Now we have three equations with three variables, so we can solve them simultaneously. You can directly plug in these equations in the calculator and solve for the missing quantities. So I'm going to construct a table for their coefficient. This will be for I1, I2, I3 and C. For the first equation, coefficient of I1 is 1, for I2 is minus 1, I3 is minus 1, constant is 0. Then for the second equation, coefficient of I1 is 5. There is no I2 here, so 0. This will be 2 and 8. And for the third equation, there is no I1, so 0. This is minus 9, 2 and minus 7. So after you plug in the values in the calculator, you get I1 to be equal to 1.39 ampere, I2 to be equal to 0.89 ampere, and I3 to be equal to 0.50 ampere. We want the reading of ammeter. The current flowing through ammeter is I2, so the answer will be 0.89 ampere. Next, we want the reading of voltmeter. Voltmeter is connected across the 5 ohm resistor, and we can find potential drop across that resistor R1 as V1, which will be current flowing through the resistor, which is I1, time its resistance. Now I1 is 1.39 times resistance is 5. That gives you the value of potential difference across R1 to be equal to 6.95 volt.